Welcome to AI in 8 minutes or less, your daily AI update. You've seen the videos, right? Humanoid robots walking, talking, and even making coffee. The future feels like it's here. But let's get real for a minute. Beyond the flashy demos, when are these things actually going to be in our homes, and what will they even be doing?
Now that is a huge claim. It was made at NVIDIA's GTC conference, which is basically the Super Bowl of AI. And yeah, on stage, they showed off robots that looked like they stepped right out of a sci-fi movie. But what's the real story behind all the hype?
To figure that out, we've got to understand two things: the absolutely massive challenges they're facing and the incredible breakthroughs that are happening right now. So let's dive in and see what's driving all this excitement.
Okay, so here's our game plan. First, we'll look at the spectacle, all the cool stuff you're seeing online. Then, we're going to get down to earth and talk about why this is so hard. After that, we'll check out the genius solution that's speeding everything up, map out a realistic timeline, and finally, we'll get a little philosophical about the big questions this all raises.
All right, first up, the spectacle. At these big tech conferences, humanoid robots are no longer a side project. They are the main event, and companies are putting them front and center to give us a little taste of the future they're building.
You know, for years, AI has been this invisible thing living in the cloud, just crunching numbers. The big mission now, the thing driving this whole movement, is to give that intelligence a body, something that can actually move around and interact with our messy, unpredictable world.
But here's the thing. Making an AI that works in the real world is so much harder than it looks. It's one thing for an AI to create a picture of a glass of water. It's a completely different challenge for a robot to actually pick one up without spilling it everywhere. This is the new frontier.
And this is the key idea we've got to wrap our heads around. We're talking about an AI that doesn't just think abstractly, it does. And it turns out doing is incredibly complicated.
What's so interesting here is just how different these two worlds are. Cloud AI plays in a nice, orderly, digital sandbox. Physical AI, though, it has to deal with the chaos of reality. Gravity, friction, that coffee table you moved. You get the idea. So if the real world is the problem, what's the hardest part to solve? Is it building a better body, or is it making the AI brain smarter?
The answer is actually data. A robot can't learn to clean a kitchen by just seeing one. No, it needs to experience thousands, maybe even millions of different kitchens to really get it right. And that's just impossible in the real world. So, how do you solve that?
Well, this leads us to the biggest breakthrough in robotics right now. If you can't get enough data from the real world, you just build a new one, a virtual one. And this is just a brilliant way to do it. Instead of one pricey robot taking a week to learn how to fold a towel, you can have thousands of virtual robots practice folding millions of virtual towels all in one afternoon. They can fail and learn at a speed that's just, well, it's impossible in real life.
This is the question that's driving the whole industry. It's like a time machine for learning. By creating these digital twins of the real world, they can close that massive data gap and teach robots how to handle all the random stuff our world throws at them.
Okay, so they've got these incredible new training methods. What does that actually mean for you and me? When do these robots finally get off the stage and into our living rooms?
The experts are actually being pretty practical about the timeline. We're not talking about a robot butler cooking you a 5-course meal tomorrow. But a little helper that takes care of tedious chores? That's a lot closer than you might think.
So these are the kinds of jobs that'll be their entry point into our homes. See the pattern here? They're tasks where it's not a disaster if the robot messes up or takes a while. They're basically the perfect first jobs for a robot.
So why tidying? Well, for one, almost nobody likes doing it. But more importantly, it involves picking up a bunch of random objects, which is the exact thing these robots are practicing for millions of hours in those virtual worlds.
But as these robots get better at doing things, they're also going to have to start deciding things. And this opens up a whole new can of worms with questions that go way beyond just engineering.
It's really important to separate these two ideas. Right now, everyone is focused on cognition, the brain. That's the part that sees a mess and figures out how to clean it. We've barely even started to think about morality, the conscience, which would have to decide if it should throw away a kid's drawing it found on the floor.
And get this, one of the wildest ideas coming from the experts is that the robot body and its brain could be sold separately. Just imagine buying a standard robot, then going to an app store to download different skills, like a Master Chef brain for cooking or a Tidy Up brain for cleaning. And that brings us to our final and maybe most important point. As these machines go from just following orders to making their own choices, we're left with a huge question. When an autonomous robot messes up, who's to blame? This isn't just an engineering problem anymore. It's a huge societal one we're all going to have to answer together.